And we're back. This is actually the next day. Last night when I paused the camera, or I guess should say stopped the recording, and went to go dump out the water and whatnot, I hadn't realized that I hadn't charged my battery for a while, so the battery actually died in the camcorder, so I decided it was kind of late and I would just go to bed and do it again today. But here we are the next day. It's all cleaned out, and we're going to go ahead and put in some safety caps today. And these are the Y2 type. Let's see if you can see that. The Y2 type, there's two types of safety, well, there's two types of safety capacitors. There's X type and Y type. Transformer sets like this one generally use the Y type, which means each line goes to one end of the cap and the other end goes to chassis ground. So there's one for each line. In series set, they're generally the X type, which go across the line, across hot and neutral. I guess one of the ways you can remember it is the X type is across the two wires. So I went here and played some little bendy here so I could fit these in. So we're going to go ahead and put those in. I went ahead and cleaned up the terminals up here on the top. So I'm going to go ahead and wrap those around. And I'm going to wrap them around the center here. Since these are safety caps, if there's a voltage spike or whatnot and they're going to need to be replaced and at some point, I'm going to go ahead and make it a little friendly, considering that since I do intend on keeping this particular radio, when these come to be replaced, I will be more than likely be the one replacing them. And I really don't want to be cursing myself in about 10 years, so I'm going to do it right the first time. I don't know if they don't necessarily have to be far apart. I'm just being kind of weird about it, I guess, so they fit into the block all nice like. Another thing I noticed, I sat here and told you how great the condition the cloth wiring is, and I noticed this with other transformers. It always seems to be the transformer wires, if any of them, are going to be the most brittle. So when I was moving the transformer wire, the insulation cracked and some of it came off, so I just threw on a piece of heat shrink there and just ignore the fact that I did use a lighter for it. Wow, my focus is just all sorts of weird today. Alright, so let's go ahead and solder this up. Oh, another thing I did was, just for the heck of it, I used my multimeter here to test the 4 microfarad capacitor that's in there. And that actually wasn't, I mean, I got a reading on it, so I thought that was kind of interesting. I might just, for the heck of it, pull out my capacitor checker and see how bad that's leaking. I'm not going to use it, but the cap obviously, but doesn't mean I can't have some fun along the way. I mean, if I've got a cap checker, I might as well play with it once in a while. So I'm just going to go ahead and, I guess you can't see me doing this. I'm just going to go ahead and wrap these around like so. Like I said, I'm not gonna wind this around. There's no point to do that, and eventually they're gonna have to be, most likely have to be replaced at some point. And might as well make it friendly, unlike the Philco people who really like to wrap stuff around. And it seems to me, now that this is my second or third radio from Philco. They were really solder happy. I have come across some big globs of solder on some original components. And, well, I guess I get to use my little solder sucker, so it isn't really that necessary to drown your connections in solder. Probably don't have to tell most of you that. So, let's do some trimming here. Don't know where that went, but hopefully it didn't end up in my foot. Alright, so there they go. They don't necessarily have to be separated, but I did it anyway. And I also realized I'm out of point 32, well, 32nd of an inch 60-40 solder. So I'm going to use this lead-free stuff, which actually is not too bad, but I do have to say, it does have, well, it's tin, so it has a pretty high melting point. Right. So, and I do not have my fan on, so I'm going to be inhaling tin fumes here. And whatever the heck this rosin is. Made out of. It doesn't smell very good. So, there we go. All nice and soldered, and it does not have a super excessive amount of solder on it. Alright, so I'm going to go ahead and put this block back in. Oh, and by the way, I did actually found a little bit of cadmium corrosion somewhere in here, so it does exist in here somewhere. And so I'm going to go ahead and put this back in, and I'm going to solder it up. One of the things I noticed, I just, for the heck of it, I got on Google last night, and I went ahead and Googled 3812 chassis, just so I could see. I figured somebody out there is going to have pictures of the underside, just to check out the wiring. This capacitor here, the original one is here, the number 4, which of course is ground to the chassis here. This was connected up over here to the ground lead, and I don't know if that makes a difference or not, but I don't know if I'm going to connect it up there, because these are line filters as well, or a little bit of a line filter anyway. And it just seems to me that if I'm grounding this filter cap to the, well, I guess it shouldn't make a difference because it's only going to go one direction. So maybe I should just, never mind, forget it. I guess maybe it isn't a bad idea. The other interesting thing was that I was reading a little bit about this 12 volt, the 12 microfarad capacitor. One thing I noticed is that the replacement, the original and the replacement, use the grounding tab, which is attached to the body of the capacitor. But this capacitor is isolated. It'd be really nice if I was paying attention. The capacitor is actually isolated from the chassis. This cardboard wraps underneath, so it's actually grounded to just the cap. And I was reading something about how this is a floating ground, I guess they called it. And something, this was late last night, so I don't remember. I've slept since then, as we say here in Texas. Something about did they say bias circuits? I wasn't sure, so I was going to do a little more investigating, because my first thought was, oh well, here's a problem. It's the caps are all grounded to this grounding tab, and there's nothing, and it doesn't go anywhere. But when I looked at pictures of original chassis, it's wired the same way as they were. with the exception, of course, of this. But this chassis also has a couple of grounding tabs around it, so I'll try it out. If it's noisy, we'll move stuff around. I mean, it's kind of how you learn, I suppose. So I'm going to go ahead and put this back and move on. I think maybe I will take this off and test this little cap off and just play with it. So I also got out my 4 microfarad and the 12 microfarad electrolytics, so I'm going to go ahead and put those in. So I will be right back. Alright, well, I'm back, and the bakelite block is in, and the electrolytics are in and tucked in as close to where they were originally located. Interestingly, I haven't pulled out the caps yet. Maybe I'll do that at another time, because of course I started poking around, and while I had, you know, wires and stuff disconnected, I started testing components, and interestingly, I found this resistor here. This one right there. This is one of the older types. Is you probably remember, but the color codes on these, you read them as body, end, and well, dot or stripe. In this case, it's stripe. So bed. So this is a 4 mega ohm, and as you can see, I have my little handy dandy clips connected on there, and I want you to see, what does that say? Open. So we've got a bad resistor there. Now I guess I should go about my business here, and if anybody's going to make a comment, well, boy, that started out kind of rude. If anybody's going to say anything about having to disconnect one end, bear in mind that this particular resistor here connects up to the terminal strip in the middle, and then continues to the screen grid wire, and then the screen grid wire for the 75 tube goes up through the hole, and as you can see, or not see in this case, there it is. It is boy, I need 4 hands here. Anyway, so the point is that it's not connected, so one end is actually technically disconnected. So I got a bad 4 mega ohm resistor that goes from the volume control to the screen grid, and so that's open, and hopefully I have well, crap, I have a 3.3, and I have a 2.4, and I have 30 mega ohms, that is. Kind of overkill there. And look, I have more 3.3s and a half watt. I'm sure 3.3 would probably be just fine. If I wanted to get really anal about it, I could do a 2.2 and a 1.5. But I think 3.3 should be sufficient. Geez, and these are all my freaking 1%ers, so. Boy, what a time for me to want my 10% tolerance ones, and hoping I get a 3.3 that reads more like a 4.0. Well, alright, so I think that's, like I said, I should be okay with that, I think. I'll poke around. I may have a 4. I don't think so. Can't remember anything I've had that's taken a 4. And I'm assuming that's a half watt. But anyway, I guess I better keep going. I may have to order some parts. I hope not. I thought I had everything I needed for this thing, but that's kind of always the case. Plus, I see buried deep inside here is another, I'm going to assume it's a 1 watt. Let's see if I can get you guys to see that. It's buried all the way. Oh gosh, I don't want to bend that wire. If you can see, there's the body of it. If this thing will focus in. There we go. You can just barely see the body of it right here with the silver end cap. And I can't read that center piece, so I'm going to assume that this is right, and it's going to be a 250 ohm. Wow, that's a half a watt. I guess these other ones must be 1/4 watt then, because this red one down here is big. So I guess these must be 1/4. I'm still not used to some of the older ones. They just seem so much bigger. I mean, geez, if this is a 1/4 watt, I don't even own 1/4 watt ones because they're so darn small that I'm afraid I'm going to lose them. Anyway, well, I'm going to wrap this up as part 2. I guess, like I said, I still want to take these electrolytics out and just test them for leakage. I was going to test the old ones for leakage too. These, by the way, tested out pretty high for 22s. I don't know when this was looked at or when these things were replaced, but you know, electrolytics go bad regardless. Oh, I guess I still have this one on. I laugh because I don't necessarily trust my EX Tech, because sometimes it's kind of a pain in the butt. On auto, it doesn't, especially on capacitors, which this one doesn't do capacitors, but oh, now it's cooperating. A lot of times it doesn't like to switch to microfarad. It stays on nanofarad. And then I have to go look up these big long numbers because apparently I can't move decimal points like most people. But anyway, so this is supposed to be a 22. It's reading in at 26. And this one here reads at 28.55. It's pretty high for these. I don't know what it doesn't have a percentage on it, but whatever. And I do believe that this is actually fairly accurate because when some of the more expensive name brand caps that have, you know, like 1% tolerance come out exactly what they're supposed to be. So anyway, I am thinking about getting a capacitor checker next. I have my eye on one that keeps going on sale for $30 because this one's limited, and when I was working on the ICO back here, not that I didn't trust the components, but I just kind of like to test them before I put them in. This does not go up high enough. I don't remember what it goes up to, but I was unable to test the 80 mega ohm, or was it 80 or 90 mega ohm that I had to string a bunch together to get. So, but the ICO works. It's not very accurate, which kind of bugs the crap out of me. You know, what do you want? It's old and it's within its tolerances, but I guess I've just used modern equipment. So I'm babbling now, and I will let you all go and see you with the next video.